This is my conversation, my Unit 3 conversation. Let's begin. Number 1. What is an Avogadro's number? What does it represent, or what is the unit of Avogadro's number? Avogadro's number is a constant that represents the number of particles in one mole of substance. It is defined as the number of atoms in exactly 12 grams of carbon-12, and it is approximately equal to 6.022 times 10 elevated to 23. The unit of Avogadro's number is particles per mole. It is a fundamental constant in chemistry, and it is used to convert between numbers of particles of a substance in its mass in grams. For example, if you know the number of atoms or molecules in a sample of a substance, you can use Avogadro's number to calculate the number of moles in a substance. So for matching the next symbols, the correct name, the moles is N, the mass is M, Avogadro's number is capital N, A, number of particles is capital N, atom is Cu, and molecule is O2. Identify the type of particle. Ne is an atom, NH3 are molecules, NaCl is an ionic compound, and Cl is an atom. Explain how to convert moles of particles to mass in grams. Identify the substance and the number of moles you have. For example, let's say you have 2 moles of water and you want to find the molar mass of the substance. The molar mass of water is calculated by adding the atomic masses of 2 hydrogen atoms and 1 oxygen atom. So the molar mass of water is 2 times 1.008 grams per mole plus 1 times 15.999 grams per mole. It equals to 18.015 grams per mole. Multiply the number of moles by the molar mass to get in the mass in grams. Number of moles times molar mass in grams equals 2 moles times 18.015 grams per mole. Mass in grams equals 36.03 grams. Therefore, 2 moles of water has a mass of 33.03 grams. What are the units of molar mass? The units of molar mass are grams per mole. Molar mass is defined as the mass of 1 mole substance, which is calculated by summing the atomic masses of all the atoms in a molecule or formula units of substance. The resulting value is expressed in grams per mole, where the gram is a unit of mass and the mole is a unit of amount of substance. How do you convert from mass to moles? First, you have to identify the mass you have in grams. For example, let's say you have 25 grams of calcium carbonate. Second, you have to find the molar mass of the substance. So the molar mass of calcium carbonate is calculated by adding the atomic masses of 1 calcium atom, 1 carbon, and 3 oxygen atoms. So molar mass of calcium carbonate equals to 1 times 40.08 grams per mole plus 12.01 grams per mole plus 3 times 15.99 grams per mole equals to 100.09 grams per mole. Divide the mass in grams by the molar mass to get the number of moles. Number of moles is mass in grams divided by molar mass numbers of moles equals 25 grams divided in 100 times 0.09 grams per mole. Number of moles equals to 0.2498 mole, rounded to 4 significant figures or dates. So therefore, 25 grams of calcium carbonate contains 0.2498 moles of calcium carbonate. What is an empirical formula? An empirical formula is a formula that shows the simplest whole number radio of atoms or ions in a compound. It is a formula that represents the relative number of each type of atom in a molecule, but not necessarily the actual number of atoms in a molecule. Which of the following are empirical formulas? The number 2 and the number 3. Based on the following balanced equation, N2 plus 3H2 equals 2NH3. How many moles of hydrogen H2 are required to react completely with 6 moles of hydrogen N2? The ratio of N2 to H2 is required for complete reaction is 1 to 3. Therefore, for 6 moles of N2, we should need 6 moles of N2 times 3 moles H2 divided by mole N2 equals to 18 moles H2. So 18 moles of hydrogen gas are required to react completely with 6 moles of hydrogen gas N2. If 30 moles of H2 are reacted, how many moles of NH3 can be produced? The stoichiometry of the reaction indicates that for every 3 moles of hydrogen gas H2 reacted, 2 moles of ammonia NH3 are produced. Therefore, we can use the mole ratio between H2 and NH3 to calculate the number of moles of NH3 produced. So continuing, 30 moles of H2 times 2 moles of NH3 divided by 3 moles of H2 equals to 20 moles of NH3. So 20 moles of NH3 can be produced if 30 moles of NH2 are reacted. What is meant by limiting reactant? The limiting reactant determines the amount of product that can be formed in the reaction. The reactant is the percent in the lesser amount will be the limiting reactant, because it will be consumed completely before the other reactants are used up. If 1.5 moles of Fe are mixed and react with 2 moles of S, which reactant is the limiting explain? So, from the balance equation, we see that the stoichiometry of the reaction is 1:1, which means that 1 mole of Fe react with 1 mole of S to produce 1 mole of FeS. If 1.5 moles of Fe are mixed with 2 moles of S, we can use the mole ratio from the balance equation to calculate the theoretical yield of FeS that can be produced. 1.5 moles of Fe times 1 mole FeS divided 1 mole of Fe equals 1.5 moles of FeS. 2 moles S times 1 mole FeS divided by 1 mole of S equals 2 moles FeS. So from the above calculations, we can see that both Fe and S are percent in excess and can potentially produce 1.5 moles of FeS respectively. However, we can only form 1.5 moles of FeS due to the limited amount of Fe. The Fe is the limiting reactant. Therefore, the Fe is the limiting reactant in the provided equation. From the balance equation, we can see that the stoichiometry of the reaction is 2, 1, 2, which means that 2 moles of H2 can react with 1 mole of O2 to produce 2 moles of H2O. To determine which reactant is the limiting reactant, we can calculate the amount of product that will be formed if each reactant were completely consumed. So for hydrogen, 10 grams of H2 times 1 mole H2 divided by 2.02 grams H2 times 2 mole H2O divided by 2 mole H2 times 1802 grams H2O divided by 1 mole H2O equals 89.1 gram H2O. And that's for hydrogen. And for oxygen, 12 grams of O2 times 1 mole O2 divided by 32 grams of O2 times 2 mole H2O divided by 1 mole O2 times 18.02 grams H2O divided by 1 mole H2O equals 40.5 grams H2O. So from these calculations, we can see that the amount of product that can be formed from the oxygen is less than the amount of product that can be formed from the hydrogen. Therefore, this is the limiting reactant, and hydrogen is in excess. Only 40.5 grams of H2O can be produced, which is determined by the amount of oxygen present. So that was my conversation, and thank you.